Hello, welcome to the I/O Hub, where we talk about the latest industry trends, hardware, and technologies around industrial and embedded computers. I'm Chris, and joining me today is Tasha Dickinson, Product Manager here at Logic Supply.
Hi, nice to be here.
Today we're going to be talking about edge servers, but before we get into that, can you give us just a quick history on how servers came to be?
Definitely. Servers have been around for actually quite a bit of time. The founder, they say, of servers is Tim Berners-Lee, and he worked for CERN in Switzerland in 1989. He actually had a problem. He needed to get all of the data from his scientists all over the world, as well as just, around the labs at CERN, and wanted to make sure that he could access them no matter where he was. Each different computer had different languages. Sometimes you had to know multiple different languages just to get data off of these different computers. And he was able to have one repository that was able to kind of amass all of this data and push it out to all of his scientists all over the world. And so that's actually where servers started, really in this content caching type of an idea. Oddly enough, he was born in the same year as Steve Jobs and Bill Gates. I thought that was kind of interesting. But he quietly, kind of behind the scenes, started this whole server history that we have to this day. He was even brought out, you might remember him in the Olympics recently, and was acknowledged by the Queen as well and knighted. But he tweeted out at that time and said, "This is for everyone." And I love that idea that somebody who started that is really enriching the history around servers. And I think we're doing it here today with Logic Supply with some of our edge servers. So I'm super excited to talk about that.
So Tasha, enlighten us. We know that servers are computers that serve as a central source of information to give resources, distribute resources across the network. But what are edge servers?
Yeah, so I think when most people hear the word server, most people think of a very cold room somewhere in the back of a building or even buried underground in cement bunkers.
Like a data center
Like
or
a data center, exactly. But I think that is kind of the model of 10 years ago. A lot of that was really for the proliferation of the cloud, as well as kind of the growth of the internet. And so edge servers really are going to be kind of the next step, what we are needing next. So, I really talked about Tim and how he had a problem and what he was, doing. As people are really looking at artificial intelligence and machine vision and learning and all of that information, we're finding that a lot of the analytics and things that need to happen are now happening farther out. They're happening farther from data centers. And I think that it's important to think about those problems that are now facing a lot of our software providers or, the people who are really inventing what's going to happen next in these technologies. So an edge server really is being able to put out a lot of the computation that you need right at the edge, right where those things are happening in our everyday life. So in NEMA cabinets, in custom-made cabinetry that is literally out in the middle of the desert, things that are in a closet in a warehouse sometimes, or even on somebody's desk right in the middle of a welding studio. All of those things are problems that people are having that we're trying to solve with edge servers.
Well, let's talk about some of those problems. So you're talking about taking what's been traditionally in these large server rooms, moving them closer to where the action is happening. What are the benefits? Like, why are people doing that?
Why? Yeah, exactly.
What problems are they trying to solve?
What makes sense? I think there's a couple different problems that we've been hearing from our customers and that we've seen as a lot of this technology has developed. I think one thing is decision making is really big, especially with artificial intelligence. The ability to make a decision quickly needs to happen with compute, right? So if you're going to react to something, so you have a manufacturing line and you have a robotic arm and it needs to either stop moving because it's gotten near a person or stop a line because it has identified something with a vision capability, it needs to be able to make that decision quickly. It doesn't have the time to go and send it to a large analytics center someplace else, make that decision, then have it send it back. It needs to stop immediately because robots don't feel, right?
Yeah.
So
there's
we
a latency involved there too, right? That's kind
Exactly.
of the crux of that situation.
Yeah, exactly. So being able to move that decision making right next to that robot or even on site is a really important thing. So that's kind of the need for that computational need. But there's also things that people are finding. I mean, cloud services, big data, all of that has been growing and growing and growing. And so we are pushing more data up to the cloud than we ever have before, because more people are collecting it. There's more data, data points, more nodes out there collecting that data. And so people are realizing as they get their bills that pushing all of that data just kind of unfiltered up to the cloud is really expensive.
So then there's that cost management piece, that
exactly.
the cost of transmitting data.
Well, it's the cost of transmitting it, and then also that cost. So, data cloud usage is usually based on the amount of data that you use or the amount of data you store. You want to store only what you really need and only what you use. And so being able to make a lot of the computational decisions ahead of time before sending it up saves you money both on transfer fees as well as cloud fees.
Okay, so what you're saying is it's doing more, trimming the fat at the source, so that what's being transmitted is a lot leaner, more efficient.
Definitely.
It's a more cost-effective way of dealing with your data.
Definitely, but it also makes sure that it's an efficient way to do it, because having extra data just kind of held there isn't going to help anybody. You really just want to find out what you need to find out, and it's being able to help people do that. Is kind of the use of the boxes, but also the use of some of the solutions that we as well as others provide. So a lot of what people are saying is that we need this computation. It needs to be right there on the line. It needs to be right next to a robot. But you can't exactly roll a rack up to a robot and just have it sit there.
Just have it attached,
exactly.
Dragging its cords around.
Exactly. So what you need is really a specially built server or an edge server that's going to be right there. So what we're looking at is how do we get that amount of compute into a size, a form factor, a reliability that can handle that robot.
Right, because we're talking about what was in a massive data center and making that small enough to go into
a box,
a robot, an enclosure.
Yep, NEMA cabinet, small NEMA cabinet, exactly. So, what we're really trying to do here is be able to have that amount of compute in such a small box and be able to connect it too.
Okay.
That's the other big thing is connectivity, because once all that information gets generated, gets sorted, gets really reacted upon, you're going to need to be able to still connect up to the cloud and or some sort of an intranet to be able to move that data around.
Okay.
Most of the time, data centers, yes, they're highly connected, but they also have massive storage centers attached to them. So being able to have that hybrid of enough storage on site, even be able to use hot swappable right there, and be able to pull your data or be able to send it up to the cloud via Wi-Fi, 4G, or really fast internet is an important thing. So that's kind of, those are the problems that we see, and that's really what we've tried to do in creating what an edge server would be. High connectivity, high compute, some storage capacity, or at least flexible storage capacity for those kinds of needs, and really, meeting the needs of exactly what that is with the right level of processing power.
Okay, so we've created this visualization of what the data center looks like, which I think most people would be able to conjure up. But what would an edge server look like? What does a typical edge server look like, or is there one?
I don't necessarily think there is. I think an edge server is what fits in the location that you need it to fit in. So one of the things that we have really concentrated on with edge servers is multiple platforms. So it's being able to have your compute in a small box, or being able to put it into a rack if you need it. Being able to program both, one platform for all of these different locations as you deploy out wherever you need it to be. So, this is where we start thinking about form factor a little bit more. So we're thinking about both, enclosed, fanned, boxes to fanless, hardened, right there at the edge type needs, and being able to have those same platforms all the way up through maybe a rack mount. Maybe you need a rack mount with multiple CPUs. Maybe you need, more storage, all of those things. So thinking about that whole breadth of what we need, or what our customers really need to solve their problems, has kind of been important as we craft what really is an edge server.
How does that transfer to the actual systems themselves, the edge servers themselves? Like, what do they look like?
So edge servers here, as we've been developing them, are kind of a wide range of form factors, really made to meet the needs of various manufacturing environments, really on the edge environments, wherever you need them to be. So we have everything from something like a K700 that has a Xeon processor that is made to go up to 70 degrees. This is maybe someplace that people aren't working. You want to grab some of the toys you brought? Definitely. So, this is something that is, wide temperature, vibration rated. It's an amazing thing that has a system that's got a Xeon processor, and it's got a ton of connectivity, which is really important, because once you make all those decisions, you still need to send a lot of that information to a common computing cloud, whatever surface that you're using. So being able to have a system like this in your portfolio is an important part of it, especially as you're deploying out, your solution to solve your problem. So there's this.
So can I see this one?
Yeah.
So something like this, what are some of the features that are like, if this is an edge server, like what makes this an edge server?
Yeah.
What can you do with this?
I think the idea of an edge server is really the compute, and it's really the connectivity, and it's really being where it needs to be. So this can handle up to a Xeon E3 2176 processor. Fantastic processor from Intel that allows a lot of compute, but it also can handle expansion. So you've got standard PoE, everything else but mod bays to give you that really fast expansion. You can do Wi-Fi on this, you can do 4G on this. So that connectivity, placing this right at the edge so that you can make the decisions, but also still be connected up to your network or to your cloud is still an important part of that.
Okay, so what I'm seeing here then is sort of the extreme end, the far end of what we would consider an edge server.
Yeah, so you're pushing this out to the edge.
Okay.
Definitely.
So that's one example. What's we've got some other toys here too.
So this, this, albeit small, mighty, is a MC850. So the MC850 is an amazing box because even for the size of it, we're getting a scalable Xeon processor in this. So that means you can go up to 28 cores, 48 PCIe lanes, allows for a really great opportunity to do compute, especially for AI. I mean, that's really built for AI right here. You have an ability to do expansion, so you can get a graphics card, a mini ITX graphics card in there. It's got a lot of power for such a small box. And the amazing thing about this is it could go on a desk, or it could go in a NEMA cabinet, or it could go, wherever you need right there on the floor with people, working hand in hand to make those decisions right there.
Okay.
And I think it's a really cool application. We've seen some applications, everything from virtual reality to parking garages to analytics to video analytics, I guess.
Yeah, like NVRs or intelligent NVRs.
Intelligent NVRs and a lot of those applications. So
things that require a tremendous amount of visual processing as well.
Definitely,
okay.
Definitely. And I think that something like this really embodies a lot of what an edge server would be, which is that compute plus the connectivity, and in a small box that allows it to go anywhere.
Okay. And this thing is interesting because this is like the MC850's sort of shorter little brother. Can you tell us a little bit about this and sort of what went into this design?
Yeah. So the cool thing, the reason why I brought this out was because this was actually a project that we did with Intel and is really the start of our story in terms of edge computing. So we created this with Intel and the idea that computing is starting to move out onto the edge. It was the first iteration a couple of years ago, and it really got us started on this journey of where does compute happen? And Intel really is the one who brought this to us and said, hey, listen, we have a lot of customers who are talking about this needing more than server processing all the way in the back room. They're needing processing right there on the edge, and this is how it kind of came to existence. I heard a story once about a guy who was in a meeting with a whole bunch of other people and trying to explain both cloud computing, and the fact that there's cloud and all this data is running around and it's all over the place, but it's starting to get a little dissipate a little bit more. It's starting to go out a little bit farther. And the guy said, oh, so it's kind of like not so much a cloud, but like a fog. And that's how we ended up with a fog box.
So this actually is titled the Fog Reference Design.
Yep.
So what did we learn with that project? What did we learn with building this reference design with the purpose for putting it at the edge to run, for this I think it was video analytics? Or image and object recognition. What did we learn there? Why did we do this?
So, I mean, first to start off with, it came from an idea that came from the needs and the problems that are out there that we're trying to solve. So this idea of compute at the edge, we had customers who were coming to us asking us for solutions, or actually in this case it was Intel. They were coming to Intel, and Intel came to us to work with them on a project like this. But we really learned that, when this was deployed out, we needed to think about not only compute, but we also needed to think about connectivity and also about scalability. So, a project like this, it was a great start, but it also wasn't able to scale up in a way that a lot of people needed. So a lot of people understand that we need to have the compute at the edge. It needs to work with the nodes that you've got out there already deployed, and it also needs to grow a little bit across your entire organization. And from that, so we've started to grow the portfolio a little bit more in terms of getting into 1U, 2U, and 4U servers to be able to really scale to somebody's operation, to be able to understand from start to finish how that data path kind of lives.
So by working with Intel and developing this reference design, we've learned that by creating networks of computers that are able to push the boundaries, or rather push the ability of compute and the connectivity closer to where it's happening, you see lots of benefits in terms of speed, response time, basically what you can actually get done at the edge.
Definitely.
Can you give us some examples of what edge servers might look like in action? Are people using these now? What does that look like?
Definitely. So right now in a packing plant, or in a kind of a separation plant, I guess it is, we have the MC850. It's in a NEMA cabinet because it's small enough to fit into something like that, really making decisions about the robotic arm that's right there, what needs to happen, doing some vision analysis, being able to kind of make those decisions right there in the location that it needs to be in.
And that's in real time.
That's in real time, yeah, definitely. I have another great example somebody brought back about our 1U servers going into a custom main cabinet that's out in the middle of a desert, that's protecting its location and being able to do security right there and the analytics right there on site. So it's a neat application, and I think there's a lot of other cool applications that are really talking about decision making where a data center isn't going to make sense. But there's also those examples in security where data centers are part of the solution as well, and so that scalability to handle both being able to make decisions right there on a site that is remote, as well as within a warehouse that's doing a lot of the analytics and everything right there, and only pushing up to the cloud what needs to happen, in parking garages and things like that. They're kind of out in the middle of wherever they're going to be. Obviously it's people, but you have to make a decision. It has to have some caching on site, and then when it's done, it's able to send all of the information back up. So license plate recognition, other visual analytics like that.
Okay, so just when you need something in real time, that's what they depend on.
Definitely.
Okay, so it's almost like an extension of edge computing, but instead of using lightweight, smaller systems, you're using more powerful, more capable systems to do that more just a demanding type of computing.
Yeah, I think with edge servers, we're figuring out how to put that power all the way out to the edge. People are requiring it with their needs. The problems that they're running into, all the way there out on the edge, is what we're able to solve with these edge computers, so the edge servers.
The smarter the industry gets, the more
I think so.
The more powerful computers are needed to actually do that and make things more intelligent.
Definitely. I mean, if you think about where the industry is really moving right now, in terms of video analytics, right now people are going out and making decisions with the video analytics in terms of security. So if you think about if you're in an event or something like that, you're able to do a lot of the analytics there to do, detection of problematic people or problematic occurrences right there. And we're working with a solution provider right now in being able to offer our solution right there at the edge to be able to do the analysis on video, to prevent, I think, crime, to prevent theft, to prevent a lot of those things that are happening. And I think that's just the first kind of foray into what is going to be happening in the future. I mean, obviously we know self-driving cars are really moving analytics to the edge in a very big way. And I think a lot of the solutions that we have, especially around, the K700, is really moving that kind of edge computing literally out to the edge and wherever else it's driving.
Yeah, I mean, how much further than the edge can you go? It's in a car.
Exactly. All the way to ports, and we're in all different kinds of warehouses and locations. Pretty much wherever you're going. I heard recently that we're helping to do some analysis as well as transmitting some data for the Tour de France, and little occasions like that it's fun to hear that our computers are really making a difference out on the edge.
As you've been developing on our edge server platform, what's excited you about that experience, and sort of as we're excited where the industry is headed, and as we're trying to help solve some really challenging problems, what's getting you energized about that?
I think one of the cool things I get to do as a product manager here, but I think it's that listening to what is going on around me in the market, in the industry, in our software providers, from our customers, and even from our suppliers. What's exciting and what's coming up. And so as we've kind of taken a look at this, and as we've really defined what an edge server is, I think being able to listen to all those different things has been an exciting part. So, we have customers who are coming to us and talking to us about their problems, and being able to work with our partners. We're going out into trade shows, and our partners are so excited to be able to say, we really had a problem of being able to do analytics right there at the edge. We have a solution to that now.
And you're talking about software partners, right?
Yeah.
Folks who need, hardware, bare metal to run their programs on.
Yeah. I think that's an important thing. A lot of our customers are similar to our software partners. They're out there solving a problem. They have a solution, maybe it's in software, and we're able to make that a reality. We're the last bit that makes your ideas and your thoughts a reality come together. So, and that happens because we're able to put the hardened industrial boards. We use great components. We work with our suppliers all the time to do long life cycle, to do really hardened components together, to be able to have that solution out there that people are dreaming of and inventing every single day, and to have it last, and to make sure that you don't have to worry about is it going to work, because your solution is going to work. We know that our hardware is going to make it work on that platform. So one of the other things I really enjoy about my job is being able to also look at where the industry is going and what's coming next. So, we talk a lot about compute, and right here, I have this Xeon Scalable Cascade Lake from Intel. I love it. I mean, look at this thing. It's a huge thing.
It's a big guy, yeah.
And we managed to put this in the MC850. But I think that there are so many other platforms too that our customers are using and getting excited about. So in addition to Xeon and to Intel in general, we're able to now move into AMD. So AMD presents a whole nother opportunity of solutions for us. So I think coming up soon, we're going to start talking more and more about AMD, what they're bringing to the game, why people should use AMD, why people should use Intel. One of the things I think we really do well here at Logic Supply is find the right solutions to the problems that our customers are asking or aren't asking. And so I think having a portfolio as we grow this portfolio, to be able to meet all of those varied needs is important. So AMD is going to be part of that solution. We're working with software partners, Gorilla and Ignition. They're going to become part of the solution. Thin Manager. All of those things are kind of part of the solution to the problems that our customers are seeing. And so I think we'll be getting more of that, especially in the edge server line, and being able to do more expansion options. Our customers are coming to us with different connectivity needs. We're getting into 5G, but we've already seen the request for fiber, being able to integrate fiber into some of these smaller boxes as part of the connectivity thing. It's kind of old hat, but being able to package it into the sizes that we're seeing is a really new opportunity for us and for the market in general. So we're excited about that.
Yeah, and because it's not a one-size-fits-all solution. There's different ways to solve these problems.
Definitely.
And what you spoke about is being able to apply these different tools, whether they're technologies, connectivity, types of processors, form factors. Yep. They all come together, and we've been able to solidify them into products that are going to solve those specific problems.
Definitely. And I think all of us are excited about that. And so, working on that and then hopefully being able to bring that here and talk to you, Chris, a little bit about some of these new things. I think that it'll be an exciting, at least next couple of quarters for this kind of edge server, as well as for a lot of other products that we have coming out here at Logic Supply.
Yeah, well, thank you for joining me and waxing poetic about edge servers.
Super excited.
Yeah, and join us next time on the I/O Hub, where we talk about edge servers and their reliability, durability, and what makes them survive any environment. So stay tuned.